Welcome to the CADWOLF tutorial on part trees. In this tutorial, we're going to start off by covering the theory of what a part tree is and how it's used. Then we're going to talk about how you set up a part tree in CADWOLF and how to build one out and how it's used in CADWOLF and the many benefits of actually having a part tree as opposed to just separate documents. So let's ask exactly what is a part tree. Any large engineering program requires a lot of different engineers working independently. To facilitate this, we divide up large programs into smaller and smaller systems until we eventually arrive at individual parts. How you choose to break these systems up is entirely up to you. The main idea is that we can give each system a unique name and then give each part a number unique within that system. By doing this, we can identify the location of any part within a massive program simply by looking at the number as you see here. Using abbreviations like this is often referred to as a part numbering scheme. A part numbering scheme is a central component in any part tree. Taking our system and arranging it vertically, you can see that as we break out the system into smaller and smaller segments, that you create a massive tree and that the part numbering scheme provides a path to find any part within this tree. This is why part numbering schemes and part trees are so useful. They provide an easy and efficient way to organize a large structure and then to work with any component within that structure. When you consider that every single part needs its separate mathematics, documentation, and CAD model, you can see how difficult it is to keep a large structure organized. This is what a CADWOLF part tree does for you. It lets you set up a part numbering scheme, then populate a tree, and then organize all of the files for mathematics, documentation, and CAD modeling in one place. So let's get started on how to set up a part tree in CADWOLF. So we start off in our desired workspace, and then we simply click the button to add a new part tree. We select the part tree, and then open the option to edit its title and set it to whatever we like. Saving this, we can simply double click on this line to open the part tree module. So there are three views for a part tree. The default view here is the tree setup. So what you're looking at the left side of the main window is how many segments you have. In our previous example, we had 5 segments where we're looking at the various systems broken out of the large space program. Here we're going to give it 4, including the last one being the part number. So you can simply click the plus icons to add new ones and then select them and edit their names. As you can see, each one also has a description that you can edit. This description doesn't do anything but provide information for the reader. So you can add as many segments as you want to. Typically, you don't want to have more than 6 or 7 because it just gets too confusing. For each segment, you're going to have a given number of options. Now keep in mind, the segment is just the level you're at, and the options are going to be the name that you're going to be able to give for each segment at that level. This will make a little more sense here in a second. So let's just give each segment some options. Notice we're providing a name for each segment as well as an abbreviation. Typically the name is going to be fairly descriptive, and the abbreviation is what's going to actually show up in the part number. So now that we've given it some options, you can edit the description for the main part tree as well. Let's go over to our part tree view and see there's nothing in the part tree now, so we can click to add a part level system, and the options you're going to have to choose from are those 2 options we gave for that top segment. So clicking on one, we were given an entry for that system. We're going to add a next level to the tree, so we're going to click add subsystem, and we're going to have separate options for the options that we added for that segment. So we can do this basically for each one. Here we forgot to add options for the tertiary systems. We'll go in and add one here. So we've only got one option, so there's only going to be one to select. So we go back to the part tree, we add the next subsystem, we select our one option. Now notice this is the lowest system. Everything after this is a part, so the only option you have is to add a part. The part is added, and as you can see, it's shown as an abbreviation plus the final level being the number that you're at. Now when you create a new part, it's going to assign a number for each part. You don't have any control over what actual number is assigned. Also notice that once a part is created, the menu offered for a part is different. You have the option here to actually open the document. So each time you create a part, a separate CADWOLF document is created specifically for that part. That is where the mathematics and the design of that part is intended to be carried out. This is important because this is where CADWOLF provides one single point of access for all of your documentation in mathematics, all through this part tree, all through this part line entry. So let's go to a part tree that's already been filled out, and let's look at one that followed the same sort of modeling that we saw in our example of a space shuttle. So what we have here is a fairly in-depth system. It's got 5 levels as our example did initially, and each level has been given a number of options for the naming of it. So we've populated the tree with one major system. We don't have a lot of options for each one, so we just went ahead and created one big system. And as you can see, it's fairly well populated. We're going to discuss what each one of these items is in detail. So going from left to right, you can see that the first entry is the name of the system. Now it's a full name until you get to the part, and when it's a part, it gives you the entire part number using the abbreviations and then the actual number. This is followed by the icon, which is taken from whatever CAD file you've linked up to it. We're going to discuss that a little bit more in a second. The next 2 items cover variables that are pulled either from the documents or from the CAD file, and we're going to give some examples of that in just a second. Before we do, let's take a look at the system we're actually designing. This is the Onshape CAD file for this particular system within the part tree. As you can see, it's just a truss. It has a ring on either end, it has 3 struts, and at each end of the strut is a separate eye bolt and fitting. So back in our part tree, you can see we have one occurrence, one line for each fitting or strut. This particular number here in the box lets you set how many occurrences there are of that part within the system. So there are 3 occurrences of the truss, 6 occurrences of the fitting, etc. This helps us add up the actual weight or cost or whatever you're adding up in the part tree, and you're going to see an example of that in a little bit. Saving this and moving on, you come to this green circle with a check mark in it. Now, this circle is green if this particular document or system is completely up to date. Nothing it depends on has changed since the last time it was saved. It'll be red if it needs to be updated. If it has a check mark in it, that means that this particular part is included in any summation that you're about to do, be that weight or cost or anything like that. If there is no check mark, that means that that system is not included. We're going to do an example of calculating the weight in a little bit, and this will be a little bit clearer. So the last entry in each line is the menu for that item. So for a part, you have the option to open the actual document. You can link that part to CAD, open the CAD file it's linked to, and a number of other things. For starters, let's go and look at the document for this particular part. So obviously we've already worked out all the math for this one, but as you can see, it looks like a standard CADWOLF document. It has all of the text, all of the equations, everything you expect to find in a document. And the math in this particular one is very simple. We simply calculated the radius of the rod needed to hold the weight given. Now let's take a look at the document for the actual strut. The math here isn't really that much more complicated. You can see that what we've done is we've taken the inner radius of the eye bolt, and based on the weight that we're holding and the material density, we are calculating the outer radius of the strut. Now, the density that we're using to calculate the weight of the strut is actually pulled in from the CAD model. That's where we actually set the density. So you can see here we're exporting a couple of variables, which is the length of the strut and the outer radius of the strut, and we're actually importing the material properties from the strut. Now that density is taken, like I said, directly from the Onshape model. More importantly, the actual load that we're holding, as well as the inner radius of the rod, are actually read in from separate CADWOLF files. So you can see this d-weight variable that we use to calculate the weight, as well as the connection points for the rod that we use to calculate the length, as well as this rod end diameter, which is actually the inner radius of the strut itself. Those are all pulled from separate CADWOLF files, and when those files are changed, this file has to be updated to accommodate that. Notice that the last thing we did in every document was calculate a variable called weight, which was simply the weight of whatever part we were designing there. What this lets us do is go into this first column here and type the name of that variable, and CADWOLF will go into each document and find the last occurrence of that variable and pull the value out here for each part. For each system, it simply sums the weight of each part. Now this is a single occurrence multiplied times that value that you gave it for the number of occurrences within that system. Now since we've linked each of these items to a CAD part or a CAD assembly, we can go into this next column and ask for any of those properties that we've imported from that model. One of these is the weight given in newtons, and what you can see here is that we need to update those values because that model has changed since we last pulled it down. And you can actually compare the weight that you've calculated to the weight calculated from the CAD model. Now obviously there's going to be some differences here because in our actual mathematics we don't account for filleting and a number of other simplifications that we've done. But what this lets us do is actually compare side by side the weight that we've calculated for each part versus the weight that the CAD model calculates for each part. Now you could do this with mass, volume, or any other property that you can import from the CAD system. So now that we've shown the benefits of actually linking our part tree to a CAD model, let's take a look at how we actually do that. So assuming you've watched the CADWOLF tutorial on linking Onshape and CADWOLF, you know that what we have to do is send variables from CADWOLF documents to Onshape parts. Now this strut that we're looking at here, this truss is an assembly. So we're going to go into the parts for the assembly, and you can see that we have variables sent just as before for the inner and outer radius and the length going into our bolts and to our fittings and everything else. You can see that we've sent variables to our feature list. Now we use those variables to drive things like the diameter of the strut, the size of the fitting, and a few things like that. So the Onshape side of this is simple. We simply create variables that we use to drive dimensions within the CAD model. So how do we link these up to our actual part tree? Well, let's go back to the menu for each part and click the Link to CAD option. And you can see that as you've seen before in the tutorial on linking to documents, you're allowed to select what document you want, what element you want, and what part you want. Once you've done this, it's linked up and you have access to all of its parameters like weight, mass, and the icon will display appropriately. That's literally all you have to do to sync it up. Here you can see you can switch to the materials, the density, and a full list of all the available properties is here. In addition to this, once you've linked to a CAD model, you can take a look at the specific properties sent with the model. These are things like surface area, the axes, and the moments of inertia. There is also an option to simply open the CAD file that you're linked to and to update the mass and material properties if you think the model has changed since it's been pulled down last. Finally, it's often necessary to control who has access to what parts. So we have a permission system that's built in to give specific users view, edit, and edit permissions to any given part document. These permissions function exactly the same as the workspace permissions, and as you can see, the window actually looks the same. So I mentioned before that we pulled in a number of variables from other documents into our design. So there's a third view here called Documents. This is where the user can just simply provide a list to a reader of what documents are important to this part tree. This doesn't actually link anything up, it just gives you a list of things that might be connected. So we've shown one document here that we call part tree requirements, and it's actually in the same folder as our part tree. Alright, so let's explain why this document is important to us and explain exactly how a part tree can be so powerful. So going back to the folder that contains the part tree, let's go into this requirements document that we listed here. So you can see this is actually a pretty short document, and what it does is it actually just lays out the X, Y, and Z connection points for the struts. It gives the weight that the struts are going to have to hold in that D weight variable. That's the one you saw imported to all of the other documents. And it gives a factor of safety, which is also imported into the other documents. So changing any of these variables here and then saving the file will prompt all those other files to update automatically. Alright, so let's go back over to our part tree real quick. And let's go ahead and display the weight from the CAD model as it exists now. And let's make sure we've got all of the most up-to-date masses, and let's pull the weight from all of our current CADWOLF documents as well. Alright, so let's go back into our requirements document and let's change that weight. It's currently at 20,000. Let's cut that in half and set it at 10,000 pounds. So before we do that and save it, let's go into our Onshape CAD model and let's just take a quick look at the size of the fitting and the struts. Just get sort of a quick visualization for how big these things are right now, because they're going to be redesigned in just a second. Alright, so let's hit enter and let that update. and then let's save the file. So since we went into each of these documents in the part tree individually, we can now update their status. You can see that it's displayed in red, which means, hey, these values or these designs depend upon that weight variable, and that variable has changed, so they are now up to date. So what you can do is go into the menu here, and there's now an option to update that document. So clicking this button actually pulls down all the equations from that document, resolves them given the new inputs from the weight, and then saves those items. So that file is now saved with the updated value, and those values are pushed to the Onshape model. We can do this again for the fitting. Again, it's pulling down all of the new values for weight and anything else you might have changed, resolving everything, sending it back to Onshape. And it appears that the strut was the only other file that was changed by changing the weight. So let's go in and let's update that that strut. So again, this is only possible because in each one of the documents associated with these parts, we pulled in those file inputs from that requirements document. So now that we've given some time for all that stuff to be pushed, let's click the button to update the masses and get the new items from the Onshape model. So take a look at what they are now, hit the button, and you can see that the strut mass, the fitting mass, and the mass of the eye bolts have changed. They've dropped to accommodate this new weight. So let's pull the new values from our CADWOLF documents, and you can see that they're basically the same. So let's go over to our Onshape model, and as you saw there, when we click over, the view refreshed, the fitting and the strut are now much thinner to accommodate the weight being half of what it was. So what we've done here in this part tree is we've set up a system where we can actually organize each file, each document for each part, and it's all accessible from this single part tree. In addition to this, if any item is changed, you see that status update within this part tree. So you know, okay, this part, the design of this part is now out of date and it needs to be updated. If you choose to do so, you can update that part directly from this window, just as we did. In addition to this, you get instant feedback for what's now changed in terms of weight, mass, or volume. This comes directly from the documents or from the Onshape CAD model. This takes a redesign of things like you just saw the truss, which would have taken probably days to go in and update all the math, update all the documentation, and update the actual CAD model itself. And instead, it just took a few seconds here. So that's important to remember. Not only did the CAD model change, but the actual values within those CADWOLF documents, the documentation itself, changed to show the new parameters. This means that you've updated the math, the documentation, and the CAD modeling in one single step. Well, that does it for the tutorial on part trees in CADWOLF. Remember, there's plenty of documentation on part trees if you felt you missed something here, and there's always the examples you can go through. For updates, follow us on Facebook and Twitter at CADWOLF Platform.